So good evening all of you, welcome back to the classes. Am I audible to all? Good evening everyone. So please comment in the chat box, is the audio and video fine? It's okay? Yeah. We have one question, do we have joint distribution? Not exclusively distributions, but like in 𝐂𝐸 I haven't seen a question on joint distribution till now, but based on conditional probability they'll give you some questions, okay? Like because many times people feel that conditional probability and joint distributions are connected, but not always, okay? So basic some basic questions which can be solved using conditional probability will be given, okay? No need of like exclusive calculation of marginal density functions and all, it's not given till now, okay? Fine. So let's see. So part 3 and of course the last part of PYQs, then we'll have the Abhyas sessions, okay? So in today's class, like if you see the schedule, like we had this portion 𝐂𝐸𝐴 today, and I think Sandeep sir has already taken the fluid mechanics last part today, okay? And then from tomorrow you have the thermodynamics by Shivam sir at afternoon 2 and solid mechanics by Apoorv sir, okay? And the sequences goes on, and this is the schedule for the Abhyas sessions, okay? Where we'll be solving some new and gate oriented questions basically in this session, okay? And this is the Telegram channel. If you want to get connected, you can just scan this group, then it will direct you to the Telegram channel where people are together, okay? So you can keep discussing or you can seek help from each other, fine? So let's start the first question directly today. So 2024, so 2024 question, 𝐂𝐸 1 mark. So let's solve this. Solution: let y be a non-zero quadratic polynomial satisfying the differential equation, okay? So y is a non-zero quadratic polynomial. So let's say, let us write the general form. Y is equal to a0 plus a1x plus a2x square. So exit essay में Laplace के questions है, Laplace equation solving, yeah, definitely. There are 1-2 questions based on Laplace equation, yes. Fine. So if this is y, then given equation is 2 plus x d square y by dx square plus x dy by dx minus ky is equal to 0 actually, okay? Where k is a real constant and y of 1 is equal to 1, of course. So y of 1 is also 1. This is one condition which is given. Then the value of integral 0 to 1 2y dy. So if you want to integrate this function, you should know these constants a0, a1 and a2 values. Only then you can perform that integration, okay? So first let us substitute this 2 plus x into the derivatives of this. If you consider the derivatives, this implies y dash is equal to a1 plus 2a2x, correct? And y double dash is equal to 2a2, correct? This is how you get the differentiations for this given polynomial. So 2 plus x into the second derivative, which is 2a2 sorry plus x into dy by dx, so a1 plus 2a2x minus ky, so minus k times of a0 plus a1x plus a2 x square is equal to 0, of course, okay? So you can see these are the different constants that you have. Now it's also given this y of 1 is equal to 1, means if you put x is equal to 1, this y value is also 1. That's the boundary condition they have given you. Y of 1 is equal to 1, of course, okay? So now if you compare, if you look at all these things, so first let us look at the coefficient of x square, for example, okay? So coefficient of x square is 2a2, because you don't have any x square coefficient here. Here you have x square times of 2a2 into x square minus k times of a2, so minus k times of a2. So this is x square term, of course, okay? 2 plus x square, where is it? 2 plus x square, okay? There is a square here, thanks. 2 plus x square, then you have the equation, of course. So let's see, this 2 plus x square plus x into dy by dx minus k times of this complete expression is equal to 0. So let's see the coefficient of x square first, or you can write the coefficients of a0, a1 and a2. So a0 times of, first coefficient of a0 is only k, okay, minus k, fine, plus a1 into, so plus a1 into, then coefficient of a1 is x minus k times a1 minus k times a1, okay? Oh sorry, x minus k, sorry, just a second. If you take a1 out, then you have kx, yeah, a1 into kx, correct now? So what would be the x square? Let's do one thing very easier. Okay, let's take x square coefficient. It would be better. So x square into 2a2, then plus 2a2 plus, here also you'd get one more x square term, so 2a2 and minus k times a2. So this is what you have. Okay, so 2a2 plus k 2a2 minus k times of a2 plus coefficient of x. So what would be coefficient of x again? So here there is no x, so here you have one x actually, a1 minus k times a1. Okay, so minus k times a1 of course. Okay, so plus x into a1 minus k times of a1, correct? That's all. Plus the constant. So what is the constant actually? So the constant value is 4a2. Then you have no constant, minus k a naught. Minus k a naught is equal to 0. This is what you get. Yes or no? 2 plus x square of course, and if you solve this, 2 plus x square into this differentiation gives you 2a2 plus x into the first derivative is a1 plus 2a2x minus k times of y, which is the full polynomial. So now if you take these values, you can see x square times 2a2 then plus 2a2 minus ka2. Okay, so this is fine. Plus coefficient of x coefficient is here a1 minus ka1, that's the x coefficient, plus 4a2. Okay, so you have 4a2, where is this? Yeah, 4a2 minus ka0. Okay, so this is the values actually. Now this is a non-zero polynomial definitely. Okay, so if this is non-zero polynomial, this term y is non-zero polynomial, correct? Non-zero quadratic polynomial. So which tells you that this polynomial is non-zero, but you can see if this is becoming a quadratic equation actually. I think something has to be modified here. X square times of this, so this has to be an identity. Okay, and you want the values of a0, a1, a2. So then y dash is a1 plus 2a2x, y double dash is 2a2, correct? So 2 plus x square d square by dx square plus x dy by dx minus ky is equal to 0. Any technique or something which we can figure out to do this? Because this terms are slightly not very good looking terms, to be frank. Any idea? Like maybe 3 variables, 3 equations. Okay, but that's going to be very lengthy actually. Okay, but it's given as a 1 mark question, so definitely there would be some technique to do this question. Y of 1 is equal to 1. So first thing you know is a0 plus a1 plus a2. This term is 1. Okay, so this is what you have. 2 plus x square d square by dx square. So I'm checking if I'm missing terms anywhere. Okay, so 2 to 4a2 minus k a0. K is a real constant. Value of integral 0 to 1 2y dy. Okay, so because if you make this as 0, then you'll get k is equal to 4, but if you put k equal to 4, this becomes minus 3a1. So a1 should be 0 in that case. If a1 is 0, then yeah, if you see from this equations, k should be equal to, sorry, just a second. So yeah, now if you solve this equation, k should be 4. First of all, k should be 4, because if you make this term equal to 0, this implies k is equal to 4. So if you put k is equal to 4, this is minus 3a1x. So a1 should be 0 in this case, and a1 is 0. That's all. Sorry, a1 is 0. So and k is 4. So this k is 4. So a0 is same as a2. If you make this term is also equal to 0, because RHS is by default zeros. Okay. So what we have is a1 equal to 0. a2 is equal to a0. a2 is equal to a0. That's what you know from this understanding. So since y of 1 is equal to 1, this implies a0 plus a1 plus a2 is equal to 1, but this a1 is 0. So a0 is equal to a2 is equal to half, correct? This is what you would get, because you can see this is all these terms are zeros definitely. So a1 has to be 0 in this case. So integration. So first of all, what is y of x? a0 plus a1x, a1 is 0, plus a2 x square actually, okay? So this is the function, right? And k is 4 of course, okay? So then integral 0 to 1 2y dx, 0 to 1 2y dx is equal to integral 0 to 1 2 times of y. So you can take half constant, then you have 1 plus x square dx. So 2 gets cancelled definitely. X plus x cube by 3 within the limits 0 to 1. So 4 by 3 should be the answer in this case. Yeah. Okay. So 4 by 3 should be the actual answer, because see, by default this is an identity. Okay. Irrespective of the values of x, this equation is getting satisfied always. Okay. So which means this coefficients individually has to be zeros. Clear? Correct na? Like we have seen some equation in the last class, like say alpha x plus beta y plus gamma z is equal to 0 for all x, y, z. Then the only possibility is this coefficients has to be 0. Okay. So same thing. Yes. So 4 by 3 should be the correct answer, which is in option D actually. Yes. Okay. Yeah, I think this could do better actually. Is this clear to all of you? Did you all understand the procedure? So first they have given you y is quadratic function. So in a quadratic function you have 3 unknowns, a0, a1, a2. So your job is to figure out what are the values of a0, a1 and a2, and first solving that they have given you differential equation. That's all. Okay. Yes. What is this guy? Okay. So let's solve this question. It's also a 2024 2 marks question last year. So solution. Let A be a 3 by 3 matrix. A is of size 3 by 3, whose eigenvalues are 2, 3 and 4. So 2, 3, 4 are eigenvalues. Okay. So 2, 3, 4 are the eigenvalues of course. Let I be an identity matrix of order 3 by 3, and A inverse is given as 1 by 2k times a square minus 9a plus 13 by some constant k I actually here. Okay. For some integer k not equal to 0. Obviously if k is equal to 0, it is division with 0, it blows to infinity. Okay. So then the value of k is dash. So A inverse is given by this expression. So firstly let us see certain things. If you pick this eigenvalue 2 for example, okay, then the corresponding eigenvalue of A inverse is 1 by 2. Yes or no? Like if you know lambda 1, lambda 2, lambda 3 and so on. Of course none of the eigenvalues is 0, then A inverse exists, and if lambda 1, lambda 2, lambda 3 and so on lambda n are eigenvalues of A, then A inverse has a reciprocal of the eigenvalues, correct? 1 by lambda 1, 1 by lambda 2, those will be the eigenvalues of course. So if you observe, for lambda is equal to 2, let's do it simply. For lambda equal to 2, this implies eigenvalue of A inverse correspondingly is 1 by 2 is equal to 1 by 2k into eigenvalue of a square minus 9a. So a square minus 9a would be 2 square minus 9 times of 2 plus 13 by 2 times 13 by k times this addition is 1 of course. Okay. So this equation has to get satisfied. Similarly if you take 3 for example, 1 by 3 is equal to 1 by 2k into 3 square minus 9 times of 3 plus 13 by k into 1 again. Okay. So this is how you get the equations. So let's see. So let's simplify for k actually. Okay. So if you simplify for k, 2 2 and then becomes 26. So k is equal to 4 minus 18. Okay. So 4 minus 18 is minus 14 plus 26 is 12. So k should be 12 actually. Okay. Like for example if you take another eigenvalue, lambda is equal to 3 in this case. Okay. So 1 by 3 is equal to 1 by 2k into eigenvalues of corresponding a square minus 9a is 3 square minus 9 times of 3 plus 13 by k into 1. So if you solve this equation, still you will end up with 2 actually. Okay. Like for example if you take LCM now, or else let's multiply both sides by 6 for example. So 2 is equal to, or let's multiply with 3 on all the sides. So this gives you k is equal to So if you multiply with 3, there comes a 3 here and there comes a 39 here. Okay, so 9 minus 27 minus 18. So 3 times of minus 18 minus 72, correct? Sorry, I think I made a mess. 9, 3 square is 9, 9 minus 27 is minus 18, and 3 times of minus 18 is minus 54. Minus 54 plus 39, correct? So minus 54 plus 39, it's giving you 15, right? K is 15 in that case. Some catch at some point. Yeah, this 2 is also there, sorry. Okay, that's K is equal to 2, but here it's not 54 by 39. You can see minus this 2 is also there. So minus 54 by 2 is minus 27. Minus 27 plus 39, K is equal to 12 again. Yeah. Similarly, you can take the other eigenvalue also. Okay, it's not minus 54 by 2. There is also this 2 here. Okay, so minus 27 plus 39. So 39 minus 27 is 12 again. So you can use it, the simple properties of eigenvalues, to get this result. Okay, no need to calculate the characteristic equation of this matrix. Okay, in fact, if you want to calculate characteristic equation, I still have a technique. Did you all understand this? If this is clear, then I'll show you the other technique to solve this question. Is this okay till this point? I've checked the eigenvalue, that's all. If lambda equal to 2 is eigenvalue of this A, then 1 by 2 would be the corresponding eigenvalue of A inverse. So 1 by 2 should be equal to this combination. Okay, that's what. Similarly, you can take 5 and you can solve, you'll end up with the same answer. So one other technique that you can have is, since lambda 1, lambda 2, lambda 3 values are given, this is 2, 3, 4. Let's form the characteristic equation. So characteristic polynomial of A is lambda cube minus sum of these elements, 5 plus 4, 9, plus, okay, then product of individual terms, 2 3s are 6 plus 3 4s are 12, so 6 plus 12, 18, 18 plus 2 4s are 8, so 18 plus 18 is 22, correct? So 22 lambda, right? 2 3s are 6 plus 3 4s are 12 plus 2 4s are 8, so 26 actually here, correct? No, 2 3s are 6, 3 4s are 12, 2 4s are 8, so 26 lambda minus determinant, so product of the eigenvalues, 2 3s are 6, 6 4s are 24, is equal to 0. So this would be the characteristic equation of this eigenvalue matrix. In fact, if you see the general form, I'll write here lambda cube minus lambda 1 plus lambda 2 plus lambda 3 lambda square plus lambda 1 lambda 2 plus lambda 2 lambda 3 plus lambda 3 lambda 1 times lambda minus lambda 1 lambda 2 lambda 3 is equal to 0. Obviously, if you solve this equation, this lambda 1 lambda 2 lambda 3 are the roots. Okay, so that's how I have formulated this equation, of course. Okay, then let's see. So if you solve for this, since by Cayley-Hamilton theorem every matrix should satisfy its own characteristic polynomial, so a cube minus 9a square plus 26a minus 24I is equal to 0. So if you multiply with a inverse on both the sides, so a square minus 9a plus 26 times I minus is equal to 24 times a inverse. This is what you get if you multiply with a inverse on the complete sides actually. Okay, so a inverse is equal to 1 by 24 times 9a square minus 9a plus 1 by 24, there is I here, so 1 by 24 times 26 I is what you would get. So if you simplify this, then this is 13 and this is 12. So this A inverse is equal to 1 by 2 into 12 a square minus 9a plus 13 by 12 times I actually here. Even in this way you can figure out this value of k is 12 in these cases. But anyway, this is the classic procedure, and since it's a competitive exam, you need not do all this stuff. You can just check with the data given in the question. If eigenvalue of A is 2, then A inverse has to be 1 by 2 correspondingly. So you can satisfy this. Okay, you can solve in both the techniques. Fine. So last year 1 mark question. So obviously to check this equation it takes only hardly 1.5 minutes. Okay, is this clear to all of you? Yes, no, yes. Okay, all of you please respond. If you have any queries, you ask me, otherwise it's fine. Okay, so then let's move forward. So let's solve this 2024 again, XC 2 marks last year. Solution. Consider the vector field F is equal to, so given this vector field F is 2x plus y square I cap 2xy plus 3y j cap. Okay, good. So this is a 2D field, and AM is equal to integral over the path CM f dot dr. So it's a line integral basically, and m can take the values 1, 2. So there are two paths along which you are calculating the integration value. Okay, where C1 is the arc of the unit circle connecting the points 1, 0 and 0, 1. Okay, so let's see. One comma 0. Okay, and C2 is the straight line connecting the points 1, 0 and 0, 1 again. The value of 2 times of alpha 1, I think this is alpha m. Okay, so this is alpha m. So 2 times of alpha 1 square plus 3 times of alpha 2 square actually here. So first of all, if you consider line integral, first let's draw the paths. C1 is the unit circle connecting the points 1, 0 to 0, 1. It's a unit circle like this. Okay, so this is C1, and C2 is the straight line connecting the points 1, 0. So obviously from 1, 0 to 0, 1. This is C2. Okay, so this is C2 actually. First, if you look at f bar dot dr bar or any path, this gives you 2x plus y square dy, dx plus 2xy plus 3y dy. Okay, so clearly this is of the form m dx plus n dy. Okay, so let's check for the irrotationality of this vector field. So dou m by dou y is equal to 2y. That's all, correct? If you differentiate this function with respect to y partially, first derivative of the first term is 0 and derivative of here is 2y. Similarly, dou n by dou x, if you calculate, you have still 2y. So which tells you that this vector function, whatever is given, is a irrotational vector function. Okay, so it's independent of the path, which means alpha 1, alpha 2 would be same. This is the first case. Okay, so alpha 1, alpha 2 should be same. This is first understanding from this integration. In exam in 2025, if questions comes like this, please don't by default put alpha 1 equal to alpha 2 or integration is equal in any path. Please check this vector. Okay, please check the condition for the exactness. Otherwise, they can happen that the vector field is not conservative and alpha 1 and alpha 2 can be different. Okay, since we have solved some 2-3 PYQs where the integration is independent of the path, it doesn't mean that all questions should have the same story, so they can change. So please check this. 𝐁𝐚𝐿 theorem is applicable only in closed curve. Yes. Okay, so now if you see, since alpha 1 is same as alpha 2, let us go to the curve C2. So along C2, x plus y is equal to 1, so y is equal to 1 minus x, and this gives you dy is equal to 1 minus x, dy is equal to minus dx. Okay, so let's calculate maybe alpha 2. Integral, what is the function? 2x plus y square. So 2x plus y square would be 1 minus x whole square dx plus 2xy plus 3y, or you can write it as 2x plus 3 into 1 minus x. This into this dy value is minus dx. Okay, so dy is minus dx. Now clearly this is a single variable integration. Okay, you see the complete integrand is in single variable x, but what are the x limits? X is going from 1 to 0 actually. Okay, the direction of the path is important. If you write 0 to 1, your answer will change the sign. But of course, in this question, since you have the squares, it doesn't matter. But in reality, when you are going in the this sense from 1 comma 0 to 0 comma 1, your x is changing from 1 to 0 actually here. Okay, so x is changing from 1 to 0. So now it's a single variable integration. Let's do this very simply. Integral 1 to 0 2x plus 1 minus x whole square. So this can be written as x minus 1 whole square as well. So x square minus 2x plus 2x, they get cancelled, plus 1. This is the first term. Then because of this minus, you have minus sign, so minus. So 2, or else let's do something, you put it as plus and write this as x minus 1. Okay, you using this minus sign, you write it as x minus 1. So 2x square plus 3x minus 2x minus 3. Okay, this full value dx, of course. So alpha 2 is equal to integral 1 to 0 2x square plus x square. 3x square is what you get, plus 3x minus x, we have 1x, 1 minus 3, so minus 2 dx, that's all. So which gives you the answer as minus 1. Just do the single variable integration. Okay, so minus 1 plus half, no, minus half, correct. So this is minus half plus 2, so this is 0.5, correct. So alpha 1 equal to alpha 2 is equal to 0.5. So if alpha 1 equal to alpha 2 is equal to 0.5, then what you can understand, therefore 2 times of alpha 1 square plus 3 alpha 2 square. Okay, so since alpha 1 is same as alpha 2, we can write this as total 8 alpha 2 square. So 8 into 1 by 4, answer would be 2. Okay, why not use Gain's theorem? Because if I use Gain's theorem in this case, first of all, it's not a closed path. Okay, you see, these are combination of two curves, but it's not a full closed loop, complete loop. Even if you apply the complete loop and if you apply Gain's theorem, you'll get 0, meaning alpha 1 is same as alpha 2. Okay, like for example, if I take the loop anti-clockwise, okay, if I change the sign of this line, the direction sense, then this is alpha 1, whatever you calculate along this path, and alpha 2. So when you do cyclic integral over the complete c1 plus c2 f dot dr by changing its sign, you would get 0. Okay, so which tells you, since you have included both the curves, alpha 1 plus, since you change the sign of c2, minus alpha 2 is equal to 0. This is what it tells you. Okay, so then alpha 1 should be same as alpha 2. Got it? It would be 0 clearly because f is irrotational. So if the path is closed, then cyclic integral f bar dot dr bar should be 0. Okay, did you all understand why didn't I use Gain's theorem? Even if I use, I wouldn't get much impact. Okay, which I know from these conditions. So the correct answer would be 2 in this case. Okay, so let's solve this. The second smallest eigenvalue of the eigenvalue problem. So these are the eigenvalue problems in the differential equations. So it's very interesting topic, basically 2023, not last year but 1 year behind, they have asked these questions. Okay, in fact this is one of my ISRO question as well, interview question. So let's see what we can do about eigenvalue problems. Normally when you look at any differential equation, for example, okay, like if that's of the form y double dash plus some constant into y is equal to 0, definitely this, so if alpha 1 and alpha 2 are not equal, then you calculate alpha 1 independently, alpha 2 independently, substitute. Okay, but in GATE exam generally I don't think they'll give two different, okay, they can give if they want. Okay, so like how I have calculated alpha 2, similarly you calculate alpha 1, you'll get alpha 1 alpha 2 values, then you know you can do the squaring, adding, whatever you want. Chalo. So like for example, you see this equation is very familiar to you. This lambda is called the eigenvalue in reality. Okay, but like if you take the simple harmonic motion, okay, this lambda is represented by omega n square. Okay, in case of natural frequency, in case of free oscillations. So whenever you see this frequency is whatever you get, okay, right now whatever the syllabus you have, at least for XC, that do not include some higher calculus. Okay, otherwise what you do is you take y dash as y, then y double dash is equal to y dash. Okay, so this is the equations you get. Then we'll see for y dash y double dash actually. Okay, so you will get some coefficient matrix and you will get some numbers. So whatever the frequencies you get are actually the eigenvalues of this particular matrix actually. Okay, like there is one very good book normally if you want to follow. There is something called Nonlinear Dynamics by Stogatz. Okay, so it's a phenomenal book. If you open that book, you'll have all the stability analysis and all, but right now I'm teaching only the maths part which is needed for the exam. Okay, but in reality if you want to understand what does this lambda and how this differential equation is connected to eigenvalue, you should go for this understanding. Okay, and the eigenvalues of this matrix is which it decides the stability, or basically the underdamped, free damped, all these like in this case the frequency of the vibrations actually. Okay, so let's look at only the maths part which is involved in this. Okay, let's not go for the physics as of now, time is short, that's why. So given d square y by dx square plus lambda minus 3 operating on y is equal to 0. Okay, and y of 0 is 0, y of pi is equal to 0 again. Okay, so this y of pi is also 0. So let's see if you solve this equation, you form the auxiliary equation. Auxiliary equation m square plus lambda minus 3 is equal to 0. So m square is equal to minus of lambda minus 3. So m is equal to plus or minus I times of root lambda minus 3 is what you have. Okay, so these are the roots of the characteristic equation in this case. So sorry, the roots of the auxiliary equation. Okay, so therefore, and right hand side it's 0. So solution is y is equal to some constant cos root lambda minus 3 times x plus sine or plus c2 sine root lambda minus 3 times x. So this would be the solution actually. Okay, now we have two boundary conditions. Definitely y of 0 is equal to 0 and y of pi is also 0 actually. So first let's go with the first boundary condition. So y of 0 is equal to 0, which gives you 0 is equal to c1. When you put 0 here in terms of x, this becomes 0, so cos 0 is 1 plus c2 times, when you put x is equal to 0, this term is 0. If you solve this equation, this gives you c1 is definitely 0. Okay, so initially there is no for other branches we can see, or it's branch specific. It's not branch specific, it's like normal maths, you can just look at. Okay, so this definitely tells you this c1 is 0, which means your solution do not have any implementation of the cos terms. So let's go for the sine terms then. So therefore y is equal to some constant sine root lambda minus 3 times x actually. Okay, then you have one more boundary condition, y of pi is equal to 0. So this tells you 0 is equal to c2 sine root lambda minus 3 times pi, of course. Okay, now I cannot make my c2 0. Why? If I make c2 0, then c1 is also 0, which means this gives you only trivial solution, y is equal to 0, which satisfies all these things. Yes, correct. Now, right now if I take this c2 is equal to 0 now, then definitely c1 equal to 0, c2 equal to 0, which means first of all this function, whatever the general solution you have, that's 0, basically the trivial solution, which doesn't give any physical sense. Okay, so that's why one possibility of this c2 being 0 will rule out. Okay, so since c2 is not equal to 0, that is to eliminate trivial solution, this implies root or sine root lambda minus 3 pi is equal to 0, which implies this root lambda minus 3 should belongs to n, where n is equal to n belongs to z plus. Okay, you can write n belongs to some positive integers definitely. Okay, why? Because when you write this equation, why I am taking n is only positive? Because if n is negative, okay, which means if this term is negative, means if lambda minus 3 is negative, then this directly gives you the real solutions, which is like the solution will never converge, the oscillations keep increasing physically. But anyway, right now you can see this should belong to n, and n is equal to 1, 2, 3 and so on. So this gives you lambda is equal to n square plus 3. This is the eigenvalues, set of eigenvalues, set of natural frequencies for n equal to 1, 2, 3 and so on. So let's see, lambda 1 is equal to, when you put n equal to 1, this is 1 plus 3, which is 4. Then lambda 2 is, when you put 2, 2 square, 4 plus 3, 7. Lambda 3, 9 plus 3, 12 and so on. Okay, so clearly these are the set of eigenvalues, the dominating frequencies, of course. Okay, so if possible, can you please repeat the previous question? Okay, I'll go, let's see. So these are the set of eigenvalues which could satisfy this given differential equation. Now they are asking you the second smallest. Okay, so this is the smallest, the second smallest is 7. So 7 should be the correct answer. Okay, yeah, Sharma correct, 7 is the right answer. If lambda equal to 3, then y double dash is equal to 0. You'll just get a linear function. Okay, then with time the oscillation amplitude is just increasing, but that doesn't give you physical sense. Okay, clear to all of you? If this is clear, I'll just go to previous question once, because some of our friends have doubt. So previous slide. See, firstly, this equations are harmonic functions. Okay, so if you try to generate the solution of that, you'll definitely get sine and cos combinations. Okay, so instead of having complex roots, if you have real roots, okay, then your function would be something like this, whatever m1 and m2 x. Okay, and this is not periodic, understood? You won't have any harmonic functions here. Clear? Which means either the amplitude of the vibration or amplitude of any wave continuously keeps increasing, which is not the physical case. 4 is the smallest, but in the question they have asked second smallest. Okay, that's why. Okay, why n equal to 0 I did not take. If I take n equal to 0 here, which tells you lambda should be 3. Okay, like the same case, if you put lambda is equal to 3, then this y is just a constant function. Okay, like if people are from heat transfer, they might have solved these equations. Steady state 1D, it's a linear function, that's all. Okay, but you should have the periodicity in the oscillations, so that's why this physically is not feasible, so we eliminate n equal to 0. Okay, because if n equal to 0, then every equation is independent of this constant, which is not the actual case. Okay, so in all eigenvalue problems of differential equations, we start the value of n with the positive integer, starting from 1 and going. Okay, is this question okay to all of you? The eigenvalue problem question. Okay, so let's go to previous question once. In this question, yeah, what's your doubt? Someone has asked me. Yeah, Preeti, yo, what's your doubt in this question? See, at any point, even if I go to future questions, but still you have some doubt in the past, please ask me. Okay, I'll try to clarify as much as I can. Yes, fine. Okay, so let's move. So let's solve this question, a simple question from limits 2015. 1 mark question, of course, some easy question. Let L is equal to limit x tends to infinity x minus sin x by x plus sin x. Plus ln x by x. Alpha 1 is equal to alpha 2 because this conditions is getting satisfied. Okay, so dou m by dou y is same as dou n by dou x, which implies the curl of f is 0. So this implies the integration is path independent. Okay, so L is equal to limit x tends to infinity x minus sin x by x plus sin x plus ln x by x. So people are ready with answer 1. Devanshu is saying 1. Anyway, let's check it up. So L is equal to limit x tends to infinity. Okay, so limit x tends to infinity x minus sin x by x plus sin x plus limit x tends to infinity ln x by x actually. Okay, so ln x by x. So clearly this limit is 1. Why? Because you have the same powers and then it's a finite valued function. So you can take x common in both numerator and denominator, you cancel them, then 1 minus 0 divided by 1 plus 0. So it's 1. Now coming to this guy, this is of the form infinity by infinity. So let's see, we can work it out using L'Hospital rule. 1 by x by 1, so which is 0. So therefore L is equal to 1 plus 0, which is 1. Okay, it should be 1. Very simple question, like 1 mark question. You should have some fun activities in between, so these kind of questions come up. Okay, fun exercise. Chalo. Do anyone have any doubt in this first part? Anyway, you might have understood this, it's very straightforward. This limit is 1. Like you take x common in both numerator and denominator and cancel it, then you have 1 minus limit x tends to infinity sin x by x. You know this value? Okay, people many times while looking at this sin x by x they put 1, but actually that limit is 0. So in first limit if you use L'Hospital, getting minus 1. You're getting minus 1. If you use L'Hospital, infinity by infinity, of course. So 1 minus cos x. But how we are calculating cos infinity value? How we are calculating cos infinity? See, if you apply L'Hospital rule, you will definitely end up with 1 minus cos x by 1 plus cos x. Okay, so then how do you substitute infinity and get cos infinity exact value? You just know that cos infinity lies in between minus 1 and 1. You don't know the exact value, correct? So that's why better than L'Hospital, you should utilize the simple understanding of the limit. Okay, you just know cos infinity. What are the value of x? It will cancel after second L'Hospital. No, it won't cancel because after applying first L'Hospital, you won't get either 0 by 0 or infinity by infinity. Got it? Once you have applied the L'Hospital, you got 1 minus cos x by 1 plus cos x. This 1 minus cos x by 1 plus cos x is neither 0 by 0 nor infinity by infinity. So you cannot go for the second L'Hospital. Got it? Is this okay? Correct, no? 1 minus cos x by 1 plus cos x is neither 0 by 0 nor infinity by infinity. Okay, so that's why you can't go to L'Hospital from there. Okay, 1 is the correct answer. So let's see the radius of convergence of the following series, power series actually. Okay, some 2015 again, 1 mark question. So let's solve this. Given series, power series, given power series is summation n equal to 0 to infinity x minus 3 whole power n upon 3 power n by n factorial actually. Okay, so we have seen, like, if you have a series u1 for a power series u1 plus u2 and so on till un to be convergent, you would get limit n tends to infinity at very large case, this un plus 1 by un, this should be less than 1 of course. Okay, so now if you consider this, so consider limit n tends to infinity un plus 1 by un, limit n tends to infinity. So first un plus 1, so x minus 3 whole power n plus 1 by 3 power n plus 1 into n plus 1 factorial into 3 power n into n factorial by x minus 3 whole power n. So this modulus should be less than 1. Okay, short brief of convergence and divergence. This is what, okay, like the summation should go to a finite value. Okay, that's all. So let's see. So x minus 3 whole power n, you'll have 1 x minus 3, then this n factorial will give you n plus 1 here and 3 factorial will give you 3 here. So now you can see this x minus 3 is unique, it doesn't depend on n, 3 is also unique, you can take it out. So therefore mod x minus 3 by 3 into limit n tends to infinity 1 by n plus 1 should be less than 1. Okay, anyway n is tending to infinity, so this is positive, and clearly you know this value is 0 and 0 is always less than 1 for whatever the value of x you take it. Okay, so therefore radius of convergence, it converges over the full plane, so radius of convergence tends to infinity. Okay, because whatever the value of x you place there, that function is always convergent. Sorry, that series is always convergent. Okay, see, in series questions, whenever you have the power series explicitly, like I think in the last 4 years there is no question unfortunately, but so this time you can get maybe like the turbo machines case in fluid mechanics. Okay, so whenever you see a series like this, okay, normally these are called the power series. I have seen even in past questions, majority of the questions are solved using the geometric progression series. Okay, so these kind of series actually. Okay, but when you get this summation and power series like this, go for this which is called the D'Alembert's ratio test. Fine, so this test is called the D'Alembert's ratio test. So we can perform this D'Alembert's ratio test. What is the radius of convergent? How to find it? See, like for example, let's say this series is given in such a form. After doing the final thing, you got something like this. Okay, for example, clear? Let's say after doing the final calculation for some series, you got it something like this. Okay, so this tells you -1 less than or equal to x plus 2 less than or equal to 1. So if you subtract 2, -3 less than or equal to x less than or equal to -1. Okay, so you can see this is the values. Now if you take the x-axis, the region over which this converges, so clearly if you make the center here, this is called the radius of convergence. Okay, it's in 1D, but normally it's called radius because in reality you can deal series with multi-variables and all, but right now in GATE we generally encounter questions only with single variable, but that's what you call the radius of convergence. Actually it's 1, basically its magnitude is 1, which you can also decide from here, such that the center is at -2 and the radius is 1, which is given by this. Okay, Normally it's written if mod of x minus a less than delta, delta is called the radius of convergence. Okay, so if x minus a falls within that delta limit, then definitely the series converges for that particular value of a. So it's infinite basically. The series converges for any value of x here. So let's solve this question. GATE 2015 XE again. The divergence of a vector field. Very simple question. So come on, do this. V bar of xyz is equal to 2 power x I cap, 2 power y j cap, 2 power z k cap. So divergence of velocity at the points 1, 1, 1 is equal to, so how do you calculate the divergence? Dou by dou x of the first function. So derivative of a power x is a power x into log a to the base e plus dou by dou y of this. In fluid mechanics you have solved a lot of divergences already. So 2 power z ln 2 at the point 1 comma 1 comma 1. So if you put x equal to 1, y equal to 1, z equal to 1 in this equation, you have 3 times of 2 ln 2. So 6 ln 2 is the actual answer. Okay, this is the question and it's NAT. So 6 ln 2, let's calculate the value. 2 ln into 6, 4.158. Okay, yeah, 4.158 is the answer. Like normally if you see the derivative of a power x okay, that's what you get. Fine. Come on guys, type in the chat box. Is this okay to all of you? Yes, no, fine. So let's go to the next question. Yeah, wave equation 2017 XE 2 marks. So it's basically a wave equation. So if u of x comma t is equal to some function g of t into sin x, basically it's a variable separable solution. So g of t into sin x is the solution of the wave equation with the initial condition u of x comma 0 is equal to 2 sin x, ut of x comma 0 is equal to 0 and u of 0 comma t is u of 0 comma t is equal to u of y comma t is equal to 0 are the boundary conditions and t is greater than 0 of course. Okay, so then the value of g of pi by 3 is dash. So let's solve this. Normally if you have a brief of wave equations, the general wave equation is u tt, means the partial derivative with respect to x is equal to del square u. So this is the general wave equation of course. Okay, and normally in Cartesian, depending on Cartesian or polar, you can expand this Laplacian. Okay, now if you see in means if you here I think they have given 1D. So yeah, 1D functions. So for 1D this implies utt is equal to some constant square uxx. Okay, just this square is to denote that this constant is positive, that's all. Okay, so c is a constant. In reality if you check, you will get c as square root of t divided by m. Okay, if you go for the little physics out of it, maybe I'll show you if I have my notes. Normally if you tie a string tight between two supports, then there is tension in the cable. Okay, and this cable has also some linear mass per unit length. So then this constant c from the derivation comes out to be root t by m of course. Okay, maybe I'll show you the maths notes which I think somewhere in August I have taught them, correct? No, so PD is just a second. Differential equations, partial differential equations. This is evenings, so mornings it's like probability and stat. So linear algebra, just a second, we have to go a bit down. maybe I'll just take 1-2 minutes to show you this. PDEs, yeah. So if you look at the wave equation solution, hopefully here, following of PDEs, boundary conditions. Yeah, I think I've taught wave equations here. Yeah, wave equation. So let's see. This is the wave equation. No, it's one of the example question. Fine, this is the classification. So basically yesterday in the last class I have just shown you b square minus 4ac less than 0, all these things, but wave equation is not specified in syllabus paper, is it? Let's check, because this question is from 2017. Acha, okay, maybe after that they have deleted. In PDEs you have only classification of second order PDEs, method of separation of variables 1D, heat equation and 2D Laplace. Okay, fine. So then no need to solve this question. Shall we solve this or shall we leave this? Okay, we'll leave this for now because time is actually short. But in reality, see, in last class I have shown you that the classification is given by b square minus 4ac, maybe in the first class, less than 0, positive, equal to 0 and all. So that actually comes from this analysis. Right now I haven't done that because of time, but you can see normally this is the generalized PDE. So this PDE you can use some chain rules and all, and you can form the given PDE into system of a linear system basically, okay, and the determinant of the system basically existing the solution of the system, unique solution or infinitely many solutions, that gives you this equations, okay. Determinant of, like I have taken this as alpha x is equal to beta is the system, so determinant of alpha equal to 0 is what gives you this characteristic equations, okay, and depending on this value of the determinant, b square minus 4ac being positive, negative, equal to 0, that tells you the nature of the solution of the PDE, okay. So let's anyway go for the wave equation, okay, then in the next class. Here it is. Yeah, this is the wave equation, okay. So you can see the wave equation basically. So normally if you have two supports, okay, like the cantilever supports, fixed supports, then if you tie a string tight, then definitely there is a tension in the string, and m is the linear mass density, and then this c square is nothing but t by m, or c is equal to t by m is what you get from the physics. But mathematically this is the equations that you have, and you keep solving them. This is the variable separable technique which gives you the final solution actually, okay. So these three are the feasible, mathematically feasible solutions, out of which this second solution is the solution which is physically also feasible, okay. But anyway, coming next, this is a simple question. I would like to tell you one thing. This c square value is 1 in this case, so you have the equation. So when you have the boundary conditions, u of 0 comma t is equal to u of length. So what is the length? X is changing from 0 to pi, okay. So pi, and time is positive of course, so pi comma t is equal to 0 actually here, okay. So which tells you that if you vibrate this string, okay, u of x comma t is the amplitude of vibration at a given point. It's normally 2D. So now if you see, generally we have to only remember the general solution of wave equation, yeah, of course, but no need to remember the general solution, especially when these boundary conditions are fixed, okay. Like if this is a wave, you can see here you have the fixed support here and here. Now if you pull this string, whatever the initial displacement you give at time t0 and you leave it, definitely this point and this point will never get displaced, okay. So the displacement at the two locations at 0 and pi, normally if this length is pi, like in this question, at x equal to 0 and at x equal to pi, the points will not move irrespective of the time. So that's why the displacement of both the points at x equal to 0 and at x equal to pi at any given time value t is 0. Similarly, since you have given some initial displacement at time t equal to 0, you will have some function, correct, where in this case it is given by some 2 sin x, okay, whatever. There is some initial displacement you will be giving, because like for example, if I pull the string to some, like let's say if initially it is like this, but now I have pulled it, say something like this, okay, I have hold here and pulled it, then at time t equal to 0, by the time I leave, it has some initial deflection, okay. So that's given by this function, like if you start from x equal to 0 towards the x axis, and then the initial velocity ut of x comma 0 is, let's say, some g of x, for example, so that the velocity is different at different locations of x. If this is the case, okay, if this is the case, then the solution, we have something called D'Alembert solution. D'Alembert solution, which is not the general solution, but this can be obtained from method of characteristics. And you can see this D'Alembert solution tells you that when this is 0, u of x comma t is given as 1/2 times of f. F is this function x plus ct plus f of x minus ct plus 1/2c integral x minus ct to x plus ct, some this function but some integrating variable, let's say g of s ds. So this is actually the solution of the wave equation using D'Alembert's principle, okay, when this is by default zeros, okay. So let's see, if you look at this case, the function here in this case is sin x, okay. So the function here is sin x, and ut, the partial derivative with respect to time, ut, okay, that gives you the velocity. So initial velocity is 0, of course, and the boundary values are zeros, of course. So you can see this function is 0, so this integral doesn't play any role in this case. So u of x comma t is equal to half times of, now this function f is sin x, so sine of c value is 1, you have seen, so sine x plus t plus sine x minus t is what you have, okay. So now if you simplify this, you have sin a cos b plus cos a sin b form, so half times of, if you see this, you have sin x cos t plus cos x sin t. Similarly here, sin x cos t minus cos x sin t, so this is sin a plus b plus sin a minus b form, so 2 times of sin x cos t is what you have, okay, and 2 and 2 gets cancelled. So this solution, the D'Alembert solution or Wesel solution of this wave equation is cos t into sin x. So this is the solution which satisfies this equation, okay, maybe this equation utt is equal to uxx and satisfy all these boundary conditions, you can check, okay. Now in the question it's given the solution is g of t into sin x, okay. So they have mentioned it, g of t into sin x. So by that understanding, the g of t function, what is a part of a solution, is this cos t, okay. And what is g of pi by something they have asked, pi by 3, so cos 60 is half, 0.5, that's all. So this is what you get as a solution of a wave equation, okay. This is called the D'Alembert solution, and even this solution is also from method of characteristics, or you can apply this solution, the general solution, which is this one, so which is this solution. So in this solution, if you apply all the boundary conditions, you will end up with the D'Alembert solution, okay. But the general form of D'Alembert solution is this, whatever I have written, okay. So please take this, I know many of you might be not aware of this, so please note the point, because if you have attended this comprehensive course by me, I would have derived all these things, but right now I am not doing it, okay. See, just take this as a solution, okay, and then try to replicate these functions for now, because at this point of time, if I try to derive wave equation, it's not very a happy thing to do as of now because time is short. But anyway, for now, get XE, this wave equation is not in the syllabus, okay, so don't worry. Maybe accidentally I have taken one question from previous syllabus, okay. Vibhu, this u basically tells you the displacement, okay. Can we solve without using D'Alemberts? Why not? You can solve. Like for example, let's see, or like you have, I'll show you what is the procedure. I won't solve fully, but I can show you. U of x comma t is c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin CPT. P is some parameter. Okay, so this is the actual general solution. Okay, now if you apply your boundary conditions, like first boundary condition, u of 0 comma t is equal to 0, which means if you put x equal to 0, you should get a 0 actually. So 0 is equal to, if you put x equal to 0, this is C1 cos 0 is 1 plus C2 into 0 plus this complete function C3 cos CPT plus C4 sin CPT. Okay, so this is what you'd get. And now clearly for this to be 0, this second bracket cannot be 0. Why? If second bracket is 0, then this is 0 for all values of x comma t. Again trivial solution. So which gives you this C1 should be 0 actually. Okay, this C1 should be 0. So likewise you keep generating the constant values C1, C2, C3, C4, P, these values using the 4 boundary conditions, then you will finally get the same solution, sin x into cos t. Okay, fine. Like as far as my idea, you will get this C3 also as 0 and P is equal to 1, C2, C4 values you will get 1. So then, sorry, not C3 is 0, C4 is 0 and then C2 and C3 values you get 1 of course. Then finally you will get the solution. One shot video of engineering maths. No, but Mahavision has happened, no? I think on Punit might have taken on GATE Wallah general channel. Okay, so you can go there. So if you keep working out, you'll get these numbers and finally you'll eventually end with the same solution. Okay, so in this question the answer is 0.5 of course, 0.5. okay, 2017, 2 marks. So let's solve this question. 2023 XE, 1 mark based on interpolation. Again, solution: if the polynomial p of x is equal to a naught, so given plus a1x x into x minus 1 plus a3 x into x minus 1 into x minus 2 actually. Okay, so this is the polynomial which is interpolated for the points. What are the points? You know, 0 comma 2, 1 comma 3, 2 comma 2 and 3 comma 5. So now once you get these 4 coefficients a0, a1, a2, a3, you want to calculate the value of the polynomial when x equal to 5 by 2. Is it going above the head? See, wave equation right now I can just only give the direct solutions, okay, like the full solutions, because at this point of time showing you how the solution actually comes is a, like you can see for example the wave equation, if I want to show you, I should start this here. Okay, like for example if I start it here, then after explaining this I should start solving the equation in variable separable forms. Okay, then for different values of k show you different solutions. Okay, like you can see, so we'll get the solution. Then so this is the complete thing which I have to do, which is a huge time waste for you at this point of time. Okay, so that's why I am just giving you the solutions. Okay, whenever the initial and final points have no displacement, then you can go with the direct D'Alembert solution. Okay, if wave is there. But anyway, I think wave equations they have deleted from the syllabus. So which batch was this taught in any English batch, of course. Okay, normally these classes I think Mahavir and Indu, I think for 2025 GATE, no, I have taught these things. Yeah, somewhere in June, July, August, that time. Okay, and after this I have solved the heat equation. Maybe after one example I have solved. See, someone has asked, no, like how do you get these constants? Like by substituting the boundary conditions. Here I would have used direct D'Alembert's solution, but I did not use directly. I have shown you using the steps and finally figured out what is the solution. Okay, like you see, this is the Fourier series again for getting the functions. Okay, actual solutions, D'Alembert solutions. This is some question, maybe heat equation or the diffusion equation we have solved again, the transient 1D which you even see in heat transfer. Okay, so all this stuff we have done, but June, no, because yeah, I remember I have, because I went to ISAV interview on August 8th. I have taken some break in your classes, correct, to go for the interview. I still remember that. August 8th and 9th, I did not take the class. Yes, you can check. Okay. Chalo, let's see. So definitely interpolated polynomial should pass through the points. So first, P of 0 is equal to 2. So this implies this value of function is 2 when this x is 0. So a0 plus, when you put x equal to 0, this and this 3 terms go to 0. Similarly, second, P of 1 is equal to 3. So 3 is equal to a0 plus. So if you put x is equal to 1, this is a1, and when you put x equal to 1, these two terms will go to 0 because x minus 1 and x minus 1. And also, you know, if a0 is equal to 2, then a1 is equal to 1. Okay, so a1 is equal to 1. Then third, P of 2 is equal to 2 actually here. Okay, so P of 2 is equal to 2. So 2 is equal to a0 plus 2a1 plus, if you put 2 here, this is 2a2 into 2 minus 1 is 1. So 2a2, and when you put x equal to 2, this term is 0. So clearly this a0 is 2. 2 times of a1 is also 2. So a2 is equal to minus 1. Okay, so a2 is equal to minus 1. So 2 plus 2a2 is equal to 0 and a2 is equal to minus 1. And fourth, obviously, let's check. P of 5, no, P of 3 is equal to 5. So 5 is equal to, so 5 is equal to a0 plus 3a1. Okay, so 3a1. So 3 2s are 6, a2 plus 3 2 1. So again this is also 6 times a3. Okay, so let's see, this a0 is 2, then this value is 3, then this is minus 6. So if you shift it, 5 and 5 gets cancelled, so a3 should be 1 again. A3 should be 1 actually. Okay, so 2 1 minus 1 1, correct. 2 1 minus 1 1. So let's say here 2 1 minus 1 1. So therefore let's calculate P of 5 by 2. So therefore P of 5 by 2 is equal to, so first a0, so a0 is 2 plus a1 into x into plus, so a1x, so this is 5 by 2 plus a2, so minus 1 into x minus 1, so 5 by 2 into 3 by 2 plus a3, which is this guy, into 5 by 2 into 3 by 2 into 1 by 2. So this would be the value actually, because you see you can just get the value of constants very simply. And now if you solve this, 2 plus 2.5 minus 15 by 4. Okay, so minus 15 by 4 plus 15 by 8, so which is minus 15 by 8. You can punch some keys directly. 4.5, something happened. Okay, 4.5 minus 15 by 8. Sorry, 4.5 minus 15 by 8, so 2.625 should be the answer. Okay, so P of 5 by 2, 2.625 should be the actual answer. Okay, let me have some water here. Okay, so 2.625, because you know whenever you interpolate something, that interpolated fit should pass through all the points. Okay, is this question clear to all of you? I am solving these questions again and again because you know lot of times these interpolation questions keep coming up. like you can see almost like once in 2 years they are coming. Okay, so you should have a good eye on this. 2 decimal places, so 2.62. So let's see heat equation, obviously. So let u of x comma t, someone has asked me in Telegram today, just before I start the class. So let's see, this is the 1D heat equation, of course, transient heat equation. So u of x comma t satisfy the initial and boundary value problem, dou u by dou t or ut is equal to 2uxx when the domain is over an interval of pi, time is positive definitely. So the temperatures at location 0 and pi are set to 0. U of x comma 0 is equal to sin x plus sin 4x when you have 0 less than x less than pi. Then the value of u of pi by 2 comma ln 5 is dash. Okay, so clearly if you look at this equation, this is quadratic in space and linear in time. So you need 2 boundary conditions and 1 initial condition. So 2 boundary conditions at any given time at x equal to 0 and x equal to pi, you know the function, and 1 initial condition. So at time t equal to 0 at any given value of x you have some function. So this equation can be solvable. Okay, so if you look at the general solution of the wave equation, okay, which is in the syllabus again. Okay, so maybe I'll solve it in the next page fully, you can see. So solution for uxx or ut is equal to c square uxx, which uxx means dou square u by dou x square and ut is dou u by dou t. Okay, so that's the notation generally used in partial differential things. So 0 less than or equal to x less than or equal to L, or in this case pi, whatever, and t is positive. Okay, so if you see this equation, it's a 1D wave equation, or sorry, 1D heat equation or the diffusion equation basically for mass transfer. So this has the solution of u of x comma t is equal to c1 cos px plus c2 sin px into e power minus c square p square t. This would be the solution actually. Okay, normally if people are from heat transfer or any mechanical domains or chemical, you guys know that if you normally write the equation dou square t by dou x square is equal to 1 by thermal diffusivity dou t by dou t. Okay, so this is the partial derivative ut and this alpha. Now since to symbolically denote alpha is positive, we use c square as a constant. Okay, that's all. Normally this is called the thermal diffusivity or mass diffusivity in case of mass transfer. So it's the same equation which you solve. But of course for GATE many people just study the lumped heat analysis and all, but there is much beyond the transient heat transfer even in 1D. Okay, so let's see. So this is the solution. Okay, so first let us see the boundary conditions. So boundary conditions, u of, so c square value is 2 first of all. Okay, so let's replace this c square with the 2. C square is 2. So u of 0 comma t is equal to 0. So which implies, so let us get the things. This equation implies, so this function is 0 when you put x is equal to 0. So 0 is equal to c1 when you put x equal to 0 cos 0 is 1 plus c2 into when you put x equal to 0 sin 0 into e power minus c square is 2. So 2 p square t, this would be the function. Okay, but you know this cannot be 0 because if this is 0 then this is 0. So you total you have this solution as 0, trivial solution. Okay, so that cannot be the case. So c1 has to be 0 definitely. Okay, c1 is 0 actually. Okay, so now what is the solution that you have? Therefore u of x comma t now reduces to some constant c2 sin px into e power minus c square p square t. But now since you see this solution is valid for any arbitrary constants, we can generalize this as sigma n equal to 1 to infinity some coefficient into sin px into e power minus c square p square t actually. Okay, is this clear to all of you? Why? Because like if you see, if I have ax, this is a solution for any value of a, then I can write this solution as x plus 2x plus 3x and so on. I can write the solution like this, correct? Because this will also be again some constant into x. Got it? So the same thing here. Okay, this from this is where you get the Fourier series actually. Okay, but right now just I'm showing you as it is, that's all. So this is the solution. Clear? Can you all understand till this point? How this summation has come is because when you have the linear equation, this is a linear equation, clearly you can superpose all the solutions. Okay, see, you wanted me to write this, correct? Now for any value of this constant and this p, this is a solution. Okay, so therefore what I am doing is we are generalizing the solution by considering all such terms, n equal to 1 to infinity, and this should have some constant. I am writing that constant as bn, that's all. It's a half sine series of course, okay, but forget about the half sine series for now. Just look at the linear function and the superposition of the solutions, that's all. Okay, because if it's linear you can do the superposition of the things, and that's how you get this summation. Okay, Vibhu, is this clear? I have only studied equation of 1D and 2D heat and wave equation. I don't know how to solve them. For now just take the solutions, okay, and using boundary conditions and initial conditions try to get the constants. Okay, that would be better, because at this point deriving the solutions and all doesn't make much sense. Okay, everyone, okay, I'm asking you for the last time, is this generalization of the solution clear to all of you? Okay, let me keep it and so type in the chat box. याद करना पड़ेगा क्या solution, इस solution को याद करना पड़ेगा पक्का. Okay, now let's see if this is the case. Consider u of, there's one initial condition, right? So consider this initial condition. So what is the initial condition they have given? U of x comma 0 is equal to sin x plus sin 4x. I think it is 2 sin 4x, no? There is 2 here I think, because what is the year? 2018. As far as I remember, I have solved this question many times of course, but typing, yesterday we have downloaded the XE papers, 2018 here. Yay, there is 2. Okay, so you should have 2 sin 4x. Okay, so it should be 2. So then u of x comma 0 is equal to sin x plus 2 sin 4x. So if you replace time t equal to 0 in this equation, so this implies summation n equal to 1 to infinity bn sin px, okay, sin px into e power minus c square p square into 0 is equal to sin x plus 2 sin 4x. Okay, so this is what you get. So basically, guys, I forgot to do one thing. Here there is one more boundary condition. What is that? U of pi comma t is equal to 0. So this tells you p should be pi, sorry, p should be n. N is some integer multiple, because you see sometimes my direct thinking gives you some problems. I'll do one thing, okay, before I go for this step I'll replace this p with n. Why? I'll show you first. Okay, this is the first boundary condition. Now when you substitute the second boundary condition, when you substitute first, you understood c1 is equal to 0. So this implies u of x comma t is equal to c2 sin px into e power minus c square p square t. Okay, so since u of pi comma t is 0, this gives you c2 sin p into pi into e power minus c square p square t. But it is clearly given this is 0. Okay, so if u of phi comma t is 0, then either C2 should be 0, but C2 can't be 0. Why? C1 is already 0. If C2 is also 0, this full term becomes 0. So that's why C2 cannot be 0. Similarly, this exponential function by default cannot be 0. So the only thing that can be 0 is this. So sin p pi has to be 0. So this gives you p pi should be equal to n pi. Pi pi gets cancelled. So you have p is equal to n, the solving of this heat equation. Okay, so that's where you can replace this p with n. So sin nx into e power minus 2 n square t. Okay, that's what you would get. So then instead of px, you can write nx. So sin nx into e power minus c square value is 2. So 2 n square t. This would be the actual function. Is this clear? Basically, I have directly skipped this part because I myself know p is equal to n, but this is how p is equal to n. Okay, so first start with the boundary conditions and then with the initial condition form this summation. Okay, clear? So then if you compare both sides, if you compare this summation with this, first if you put t is equal to 0, because u of x comma 0, so if you put t is equal to 0, this full term becomes 1. Why? For any value of n, this becomes e power 0, so e power 0 is 1, which means you have summation n equal to 1 to infinity bn sin nx is equal to sin x plus 2 sin 4x. So what does this tell you? This tells you b1 is equal to 1, b4 is equal to 2, and rest all b2, b3, b5 and so on, all are zeros. Okay, this is what it gives you. You can alternatively get these functions using integration of half range Fourier sine series, but right now just you can, by visualization, you can figure out that only b1 and b4 terms will survive with the coefficients of 1 and 2, rest all terms would go to 0. Okay, instead of 0. Obviously you have to eliminate the trivial solution. See, if trivial solution is always a solution, correct? No need of any boundary condition, no need to solve the equations. I can say u equal to 0 satisfies everything. Okay, to tell that you need not be a very big mathematician, but the idea is to get the specific solutions. Okay, so from this, since you figured out u of x comma t is summation n equal to 1 to infinity bn sin nx e power minus 2 n square t. So this is the solution, but you figured out these values. So you have u of x comma t as, when you put n equal to 1, b1, so sin x into, so when you put n equal to 1, this is e power minus 2t plus, then when you put n is equal to 4 actually. Okay, so when you put n is equal to 4, it gives you sin 4x or 2 sin 4x into e power minus, when you put n equal to 4, this is minus 32t, right? That's what you get now. N equal to 4 gives you sin 32t. So this is the full solution of this equation. Okay, so this is the full solution. See, you haven't done anything, you know the general solution, you got the values of c1 and p, then equated the terms on both sides. Okay, so this is the final solution. Now let's go for the thing what they want. U of pi by 2 comma ln phi. Okay, so u of pi by 2 comma ln phi is equal to, so you want the temperature at a location, basically the value of u at this location x and at this location of at this time. So sin pi by 2 into e power minus 2 t, so ln 5, okay, because t is ln 5, plus 2 sin 4x, so 4 into pi by 2 into e power minus 32 ln 5, but clearly this term is 0 because it's sin 2 pi. Okay, so the second term goes to 0, sin pi by 2 is 1, so you have finally e power minus 2 ln 5, so this gives you minus 2. If you shift up, then e power, so this value is 1 by 25, that's all. So 1 by 25 is the solution of this function at this coordinates. So 1 by 25, let's check. 1 by 25 okay, or NAT. So 1 by 25 is 0.04, correct? Obviously, because 1 by 100 by 25 is 4, so 1 by 25 is 0.04. Why are we generalizing the solution? Because if you don't generalize, you won't be able to capture the higher nodes. Okay, means at larger values of n, whatever is the significance that is there, you will miss that. But in the boundary conditions, it's given clearly, you should involve terms of sin 4x. Okay, so 0.04 would be the actual answer. So let's check if we have the answer key here. End of the question paper. We have the answer key here or no? This is 𝐂𝐸𝐴 11th question. Okay, we had got answer key 𝐂𝐸𝐴 11. General aptitude 𝐂𝐸𝐴 11. Yeah, you can see this is the 11th question basically. 11th question and 0.04, which is 1 by 25. Okay. Because I definitely don't do wrong in these questions because I solve 1D, 2D heat equations every day in and day out. Okay. But anyway, mathematically this is the solution, but physically it has a lot of sense, which we'll look sometime later. Okay. Fine. So 0.04 is the value of u at the location of pi by 2, comma ln 5. Okay, so this is the general solution of the wave equation, sorry, the heat equation. C1 cos px plus C2 sin px into e power minus c square p square t. Yeah, definitely. If there is multiple nodes, you should keep generalizing, definitely. Okay. But this is the general solution. I think one more question has come. I think I have put that also today, maybe. So let's see. Yeah, here it is. It came in 2023. This is also a heat equation. Come on, solve this question. The domain is from 0 to 2. Okay. So solve this. So let me just write the given data first. ut is equal to uxx, and it's a 1D transient condition, sorry, conduction of 2. Okay, some partial differential equation with 0 less than x less than 2. Okay, that's what you can see, 0 to 2, and time is positive. Of course, u of x comma 0 is equal to sin pi x. So the initial condition they have given you is sin pi x. There is only one node. Okay, see, it's always better to generalize. Okay, it's always better to generalize and then get the necessary coefficients. Okay, so sin pi x, and this initial it's 0. So u of this is initial condition. Then you have the boundary values, boundary value problems, boundary value conditions. So 0 comma t, 2 comma t is equal to 0. Okay, so these are the boundary conditions, and obviously you need this because it's quadratic in space, I mean second order in space and first order in time. So definitely 2 boundary conditions and 1 initial condition is needed to solve this. Okay, then so let's see. What I want to solve this. Okay, fine. So you need u of 1 by 2 comma 1. So first of all, what is u of x comma t? That's the question. Okay, so let's start with the generalized solution. So for 1D equation, heat equation, u of x comma t is equal to c1 cos pt plus c1 cos px plus c2 sin px into e power minus c square p square t. Okay, and what is the value of c square? You can see normally c square should be here, but this c square value is 1. So this is 1 actually here. So e power minus p square t. I am writing it directly. By this time you can acknowledge this. So e power minus p square t, because c square value is 1 anyway. Okay, now in this you have to figure out what is c1, what is c2 and what is p. So 3 things, and you have some conditions to work out. So first let's start with the boundary conditions as usual. So 1, u of 0 comma t is equal to 0. So this gives you 0 is equal to, okay, u of 0 comma t is equal to 0. So this value of the function is 0. When you put x equal to 0, c1 into 1 plus c2 into 0 into e power minus p square t. This is what you get, and undoubtedly this gives you, because of the logics what I have told you, the C1 is equal to 0. The first condition gives you C1 is equal to 0, correct? So undoubtedly this term is 0, so this goes away. Then let's go here. Second condition, u of this guy, what is the second boundary condition? U of pi comma, no, 2 comma t, no, 2 comma t is 0, so u of 2 comma t is equal to 0. So 0 is equal to, since C1 is 0 now, C2 sin 2p into e power minus p square t. So clearly again this cannot be 0, C2 also cannot be 0, so this gives you sin 2p is equal to n pi. So this gives you 2p, sin 2p is equal to 0, sin 2p is 0, so 2p is n pi, so p is equal to n pi by 2. This is what you have. So p turns out to be n pi by 2. It's not always like p is n or p is a fixed value, it depends on the boundary conditions what they give you. Okay, sorry, 1 minute, I'll have some water. Are you all understanding things? I know I'm going a bit fast, but at this time if I want to cover maximum things which comes in exam, I should be at this speed. Okay, and obviously these, especially in the partial differential equations, you need a lot of understanding. For now I'm teaching this as a mathematics, or let's say just like some substitution based questions. Okay, I'm giving the solution so that you have the boundary conditions or the initial value conditions, so the initial conditions you should substitute. N should be even, is it? 2p is equal to n pi, so need not be right. Why n should be even? N can be odd. Like for example, if this is pi, then also sin 2p is 0. Okay. This type of question was in mech also. Yeah, mechanical, obviously man. You're doing mechanical engineering, you should know what is 1D heat transfer conduction equation, transient heat conduction equation. Okay. In fact, if you see for so many of the legends, self-declared legends, the transient heat conduction is only up to lumped system analysis. Okay, but you should definitely know. If you tell them I have studied heat transfer, then they'll ask you, okay, at least tell us the 1D unstudied things. Okay, chalo, let's see. So p is n pi by 2 and all doubts got cleared. Okay, so then therefore u of x comma t can be generalized as summation n equal to 1 to infinity some constant into then sin px. So sin p, so what is p? N pi x by 2 into e power minus p square t. So p square n square pi square by 4 t. This is the generalized solution. Okay, so if this is the generalized solution, you have the initial condition, this guy, let us replace. So then since u of x comma 0 initial condition, yeah, so this is sin pi x. Okay, so u of x comma 0 is equal to sin pi x. So let's substitute t is equal to 0 in this. If you put t equal to 0, this term becomes 1 anyway. Let's write this, n equal to 1 to infinity bn sin n pi x by 2 into 1, that's all. Why it's 1? Because if you put t equal to 0, this is e power 0 1, so this complete block gives you 1 is equal to sin pi x. So if you compare both sides, okay, this straight away gives you like for n equal to 2, so b2 is equal to 1, that's all. Okay, and if you put n equal to 2, 2 gets cancelled, so sin pi x will come when n equal to 2. Rest all b1 b3 b4 blah blah blah, all these things are zeros. Okay, so which means your solution is only consisting one term. So u of x comma t is equal to b2 into sin, so when you put n is equal to 2, this is pi x, so sin pi x into e power, so when you put n is equal to 2, this becomes 4 gets cancelled, so e power minus pi square t, that's all. And at rest all other values of n, these coefficients are zeros, so this is the only term which survives. Okay, that's all. Clear? So that's the solution. Now they have given the points. They have asked something which is it should be there. E power pi square into, therefore e power pi square into u of half minus 1 half comma 1 minus u of 3 by 2 comma 1 actually here. Okay, so this gives you e power pi square into u of 1 by 2 comma 1. So if you put 1 by 2 comma 1 in this equation, 1 by 2 x equal to 1 by 2, so this is sin pi by 2 1 into, then if you put t is equal to 1 in this, so if you put t equal to 1, you will just have e power minus pi square minus u of 3 by 2 comma 1. So if you put 3 by 2 here, then sin 3 pi by 2 is minus 1 into, again if you put t equal to 1, this is e power minus pi square. So definitely this e power minus pi square can be taken out and cancelled with this, so 1 plus 1 is 2. So the temperature, or basically this value of e power pi square times u of half comma 1 minus u of 3 by 2 comma 1 is 2 in this case. Okay, that's how the answer is 2. These questions are not very tough questions or something very lengthy, they are simple questions. Okay, the only thing is you should know that these are the solutions. Okay, in fact in GATE the questions are pretty easy, that you can just compare and get the values of b1 b2, these coefficients. But if they give you some complicated function, normally you get the answers using Fourier series. Okay, the half range Fourier sine series, like which I have taught in the class, the full-time class of course. So maybe this one, no, this one. Okay, so you can see this is the heat equation we have solved, and okay, maybe in the next part I have given the it should be somewhere here. Okay, the partial differential equations. So maybe here I would have taught the Fourier series part. This is a solution of the Laplace equation. Okay, okay, fine. Maybe I have taught it some different location. In the Fourier series I might have taught same PPT, wave equation. Okay, in the wave equation PPT I have taught. Okay, wave equation PPT. Yeah, here it is. Okay, so these are the Fourier half range sine series functions. Normally what we are doing in this case, once you know the function, actually we are comparing, okay, to get the coefficients, but that coefficients can be actually calculated using Fourier sine series like this. Okay, but for now you just don't focus on this, focus only on how to solve the heat equation questions. But see, these are the questions where they are asking you the function value. Okay, like for example this is NAT. Okay, this is NAT, numerical answer type question, that came in 2023. Okay, so then definitely you have to figure out what's going on. Okay, is each and everything clear to all of you? So classification, this heat equation questions, variable separable forms, you should be able to know. Okay. And anyway, variable separable forms and Laplace equations, anyone, either me or Puneet sir, whoever has taught it, we would have taught definitely. So these are the partial differential equation questions. Anyway, let's go back to our story of solving the questions. So let's see some question from probability, again 2023, 2 marks. Solution. The probability of a person telling the truth is 4/6, means out of his 6 statements only 4 are correct. An unbiased die, means basically a fair die, okay, is thrown by the same person twice, and the person reports that the number appeared in both the throws is same or are same. Then the probability that actually the numbers appeared in both the throws are same is dash. Can someone, before going to the solution of this question, can someone just comment on what is the thing that I can use to solve this question? Can you tell me some concept which I can use to solve this question? Let's say I'm not getting any idea to solve, for example. Okay. Can someone suggest me what can I use to solve this question? There is a person who speaks truth only 4 out of 6 times. Okay. Conditional probability. Okay. Fine. In conditional probability, we can use Bayes theorem. Okay. So let's see. First, probability of person speaking truth is 4/6, or this can be, okay, let's leave it as 4/6. Fine. Okay. Now, an unbiased die is thrown twice. Okay. Yeah, Bayes theorem. Good. So if an unbiased die is thrown twice, what is the probability of getting same number on both the tiles? Nothing but 6/36, correct? Because you know, total, if you roll 2 dice or if you roll a die twice, total number of elements in the sample space is 36, because in the first tile it can go in any of the 6 outcomes, in the second tile also it can go in any of the 6 outcomes. So 6 6 are 36, but out of these 36 elements in the sample space, either both the dice can show 1, or both can show 2, or both can show 3. Similarly, both can show till 6. So there are 6 elements which favor the happening of the same number in both the tiles, okay, which is 1/6. So this implies probability of not same is equal to 5/6, correct? This is not same. Now, the person reports that the numbers appeared in both the throws are same. Okay, so he told that person reported same numbers. Person reported that it is the same, but this guy can also lie, correct? So this guy can also lie. So what you can do is actually same. So this is what you have the Bayes theorem. When the main event is in the denominator, you should go for Bayes theorem. Okay. Actually same is just a possibility of this person reporting same. Okay. Same by person reported same is equal to, so how do you do this? What is the probability that he reports the numbers are same? First probability is you got the same numbers and the person told truth. This is one case. Okay, really, like in actual case, these 2 dice has given the same number, and this fellow also not lying. Okay, he is telling the truth. In this case, definitely the person will tell you that both the dice are same. Or you did not have the same number in both the dice, but this fellow lied. Okay, in this case also the person reports that both the dice has shown 6 or the same number, correct? Did you all understand this? This is the total probability of the person reporting that the dice has shown same number. In one case, the dice actually shown the same number and he reported the truth, or the dice did not show the same number but he actually lied in that case. So these are the only two cases in which he can say that it is same. Okay. Now out of these two, which is the case? So there are two cases. Okay. So out of these two cases, which is the case in which actually the die shown equal numbers? First case and second case. It's first case, right? So P of S intersection T. That's all. So this gives you probability of getting same number 1/6 into probability of this person telling truth. So 1/6 into 4/6 plus it is not a same but he actually lied, so which is 2/6. So this gives you 36 gets cancelled, 4/14. That's all. So 4/14 0.2857. Okay, 0.285. In Bayes theorem, always the main event, see, this is one of the possibility of this to happen, correct? So when possibility is on the top and the main event is in the denominator, you should go for Bayes theorem. Okay, and then figure out all the possibilities of the main event, then out of them which is favorable for the top, you just copy the term on the top. That's all. Okay, so it should be 4/14, 0.285. Yeah, 2/7 obviously. Okay, some matrix from 2014, some fun stuff. Let's see. Let smaller and smallest are real numbers. Okay, if A is equal to some matrix and B is some vector, then the system of linear equations Ax is equal to B has no solutions for S not equal to 2R. T structure. What is T structure? I don't know what is T structure, to be frank. What is T structure? This truth, then lies, this some. You want me to go with a T? But Bayes theorem for this small, this is a very simple question, right? It's a acha, okay. Maybe I was not aware of that, but to be frank, like anyway, it's a simple question, it's a one line answer. Okay, straightforward. Okay, maybe it's like the person telling truth, then the person is lying, then it's actually, so multiplying these two, add it, then take the actual case and put it. Is that the way? Yeah, because this is mathematical. If you put in diagram, that's how the diagram should get constructed ideally, right? That's what one should do. Whoever teaches this, definitely this mathematical equation can get converted like this when, if the person decides to speak truth, definitely it should be same. If the person decides to say lie, then it should be not same. So this into this plus this into this. That's what you have here. Out of this, the first case is the favorable case. Okay, that's, yeah, maybe then this is the trick, but the same thing. Yeah, okay. One is the mathematical form and one is the bit of geometry, whatever you call it. Okay, some T. Nowadays, you know, my English is also so bad. Chalo. So let's see. Yeah, there is a system, linear system. We should figure out what's happening to this system. Okay, MCQ. Okay, maybe what's the year? 2014, long back. Solution. So A is equal to 1, 2, 0, 2, 0, 3, R, S, 0 actually. Okay, and what is this vector? B is equal to 1, 1, S minus 1. 1 s minus 1 actually. Okay, so then let's see, this system has unique solution, no solutions, whatever, infinitely many solutions. So for Ax is equal to b, if you consider the augmented matrix, A augmented with B. Okay, so if you augment A with B, then you will have, you'll have 1 2 0 2 0 3 r s 0 1 1 s minus 1. Fine, so this is what you get actually. Okay, r s 0 and here. So let's see what is being asked here. R s 0, then the system has, so what is the story here? So let's see, let us get this to row echelon form, of course. So let us make this things, r2 changes to r2 minus 2 r1 and r3 changes to r3 minus small r times r1. Okay, small r times r1 actually. Okay, so then this gives you the system 1 2 0 1, then 2 minus 2 times of 1 0, 0 minus 2 times of 2 minus 4, 3 minus 2 times of 0, so 3, 1 minus 2 times of this minus 1, then r minus r, this is 0, s minus 2r, so you have s minus 2r, then 0 minus 0, it is 0, s minus 1 minus r, so s minus 1 minus small r. So this is what you have, of course. Okay, then in this case let's see, so this is what you get, of course. Okay, and here this element is 0. So now the question is roaming about s is equal to 2r. Okay, so if s is equal to 2r, so for s is equal to 2r, this implies s minus 1 minus r. So let's do one thing, let us consider the options. For s minus or s is equal to 2r. Okay, so if this s value is equal to 2r, then this element becomes 0. Okay, then if this system has to have a solution, this should also be 0, correct? Yes or no? Because it cannot be like 0 into x plus 0 into y plus 0 into z is some number, you cannot have that. Yeah, so if also if s minus 1 minus r is equal to 0, so this tells you s minus r is equal to 1, and if s is equal to 2r, so r should be 1 and s should be 2 actually in this case. If this is 0 and this is also 0, then you would get infinitely many solutions, correct? So in this case, for s is equal to 2r and r equal to s is equal to 2r, so s is equal to 2, so is equal to 2, this system has infinitely many solutions. Because this becomes an identity, so you have only 2 equations with 3 unknowns, you can end up with infinitely many solutions. Infinitely many solutions. Okay, and for example, if s minus 2r is not equal to 0, okay, this is one case, this is one case when can happen, because if s is equal to 2r and if you also make this as 0, then ultimately it has infinitely many solutions, and if s is equal to 2r but this is not equal to 0, then no solution, and if s minus 2r not equal to 0, then you can convert this into a 3 by 3 matrix, so in this case unique solution. Unique solution in this case, correct? Then because this element won't be 0, if you try to convert to echelon form, this 0 0, but here you will get some number again, so that definitely changes. Okay, so unique solution. So let's look at the options. The system has no solution if s not equal to 2r. If s not equal to 2r, this system can have unique solution actually. Okay, so this statement is wrong. Infinitely many solutions for s is equal to 2r not equal to 2. So this statement is also wrong, because if you want infinitely many solutions, this S should be equal to 2R, but that should be 2. It's given not equal to 2, so this is wrong. A unique solution for S is equal to 2R. First of all, if S is equal to 2R, you'll have infinitely many. Infinitely many solutions for S is equal to 2R is equal to 2. Yeah, this is correct option. Option D is the correct statement. Okay. Like, you can check it up. If this is the case, which means if this element is becoming 0, for infinitely many solutions to exist, this should be 0, which is this case. If S is equal to 2R, but if this is non-zero, then no solution. Okay, and that's the case of the unique solution. Is this question clear to all of you? Everyone, type it in the chat box. Is this okay? Fine. So D should be the correct answer. It will have infinitely many solutions if S is same as 2R and S should be 2. Okay, or maybe R is equal to 1, whatever. If you have any doubts in this question, you can ask me. Nothing? Everything going good? Fine. So let's solve this. A vector field is called solenoidal if its divergence is 0. Good, happy. Consider the vector fields P and Q. So this is P and this is Q. 2011 XE1 mark. The year when India has won the World Cup. So Q is equal to XYZ square P bar of XYZ. So P and Q are both solenoidal. P and Q are both solenoidal. P is solenoidal but not Q. Q is solenoidal but not P actually here. Okay. So first let's see. Solution. Given P is equal to eight xy square z I cap plus 3 x cube y minus 3 xy j cap minus 4 y square z square plus 2 x cube z k cap. Okay, so this is k cap. So if you calculate the divergence, infinitely many solutions, please explain. In this case, if this is 0 and this is also 0, okay, then it's like you have only 2 equations with 3 unknowns. Then you'll have infinitely many solutions. Okay, so equating this to 0 gives you this, equating this to 0, you have this. So if you solve, you will get this. Okay, if you put S is equal to 2R, then R is equal to 1 and S equal to 2. Okay, so let's solve. So divergence of P, if you calculate dou by dou x of this, so 4x plus at that time GATE was descriptive exam. Okay, so sorry, offline exam. So 4x plus then 8y square z plus 9x square y minus 3y minus 6x square z. Okay, minus 6x square z. So clearly this is non-zero, right? It's non-zero. So both P and Q are solenoidal. This is wrong. P is solenoidal. This is wrong. So let's check for Q. So similarly, Q is equal to xyz square times this vector P. So 2x cube yz square plus 8x square y cube 8x square y cube z cube. You should be very careful. Okay, 8x square y cube z, that's what. Okay, so y cube and z cube, correct? No, z into z square, z cube, yeah, times I plus jth component. Jth component gives you xyz square into ax cube y, so 3x power 4 y square z square minus 3xy into this, so 3x square y square z square times j plus divergence of grad p. Okay, let's solve. Otherwise I would have solved using vector identities, but it's okay. Remembering all these vector identities for 5 times. Normally this is divergence of q is nothing but it's something like this, divergence of p phi. Okay, so it's a function again, but anyway let's see. So minus 4 xy cube z power 4 plus 2 x power 4 yz cube times k. So now calculate the divergence of this. So if you calculate the divergence of this, normally what is this expression? If I remember, it's like grad phi dot p plus phi times divergence of p. Yeah, as far as I remember, this is the actual answer. Gradient of phi dot p plus phi times of gradient of p. Anyway, better to calculate this than doing again all this stuff. So if you do partial differentiation with respect to x, then 6 x square yz square plus 16 xy cube z cube. Okay, then plus 12 x cube y square z square minus 6x y square z square minus 4 y cube z power 4 plus 8 x cube yz cube. So if you simplify the terms, okay, x cube y z cube, seriously it's giving yes, this is minus, no, just check it. D is solenoidal. Okay, fine. So 6 x square yz square plus, okay, these are not partial derivatives with respect to x, sorry, these terms would be wrong. Yeah, so then you have with respect to y, you do this, gives you 6 x power 4 yz square minus 6 x square yz square plus, okay, minus with respect to z, if you do 16 xy cube z cube minus 6 x power 4 yz square. So then if you see this term and this term cancels, then 16 xy cube z cube minus 16 xy cube z cube, 6 into 6, so this is also 0. So q is solenoidal but not p. Okay, del dot p, you have calculated, no, del dot p. Del p vector x plus x cube आ रहा है. Whatever, one thing that you know is it's not 0 straight away. Okay, this is non-zero at all. It's not 0 at all the points. It may be 0 at some specific points, but not at all the points. Okay, so p is solenoidal but q is not solenoidal. Fine. It's okay. Is this clear? Abhyas sessions. Okay, as of now I can tell you only that, or else you can solve all the PYQs, and wherever you get doubt you can ask me. Solve this question. 2011 again, 1 mark. The eigenvalues of a 3 by 3 matrix P are 2, 2 minus 1, then P inverse is equal to. So since for P lambda 1 is equal to 2, lambda 2 is equal to 2, lambda 3 is equal to minus 1, therefore characteristic polynomial of C is lambda cube minus 2 plus 2 4, 4 minus 1 3 plus 4 minus 2 minus 2, so this is 0 minus determinant is minus 4 is equal to 0. So this gives you p cube minus 3p square plus 4i is equal to 0. Okay, that's all. Correct, no? So it should be plus 4i. So then you want p inverse. Okay, so this gives you p square minus 3p plus 4 times p inverse is 0. So p inverse should be 1/4 times 3p minus p square. Or minus 1/4 times of p square minus 3p, whatever. Or plus 1/4 times of 3p minus p square. Yeah, you can go with this first option. A is the correct answer. Okay. A, option A is correct. Yeah, A should be the correct answer. Okay, obvious, very straightforward. Okay, clear? If you have any doubts, you can ask me always. Okay. Meanwhile, I'm putting some 1-2 simple questions so that you'll feel little relaxed after some time. Next, 13, 1 mark. Yeah, this is a good question. The value of integral I is equal to solve this. I'll give you some time. Solve this question and tell me the answer. Okay, so first of all, when you have something with a negative sign under the root, your main idea is whenever the square root in the denominator, whenever there is a square root in the denominator, you should have eliminated that square root. Mic is on, no? Yeah, okay. So, and then you should also take care of this minus sign. Okay, so what we can do is let minus log t to the base e is equal to x. Okay, so let's take this as some variable x. So then this gives you e power t, or minus log t to the base e is equal to x actually here. So minus t is equal to, or t power minus 1 you can say. So t power minus 1 is equal to e power x. Okay, so t power minus 1 is equal to e power x. So if you differentiate this, just a second guys, if this is x, then let's differentiate this, no need of doing all this stuff. So if you differentiate it on both sides, minus 1 by t dt is equal to dx. So dt is equal to minus t times dx. And what about t from this equation? T equal to e power minus x. Okay, so t is equal to e power minus x. So let us dt in terms of x actually now. So minus t is e power minus x dx, and you have the substitution for this log t. Okay, now since you are making some substitution, definitely should end up with changing the limits. So lower limit t is equal to 0, this implies x is equal to minus ln t, so this implies x tends to infinity. Okay, because log 0 is minus infinity, so minus of minus x goes to plus infinity. Similarly, upper limit t is equal to 1, so this gives you x is equal to minus ln 1, so x is equal to 0. So therefore this integral gets converted to I is equal to integral, lower limit is infinity, upper limit is 0, then this dt is minus e power minus x dx by root x. Okay, so you have square root of x. Using this minus sign, I can swap the limits, point number 1, and root x if I take up, this can be written as 0 to infinity e power minus x. If this goes up, x power minus half, so that can be written as half minus 1 dx. So clearly this is a gamma function. Gamma function, and this is equal to gamma of half, which is equal to square root of pi. Okay, that's the case. So root pi should be the correct answer. B is the correct आंसर. ओके, तो एक्सी के लिए एटीडी में कौन कौन टॉपिक इंपॉर्टेंट है? वन इज साइकोमेट्री, लाइक यू गेट लॉट ऑफ नाइस एयर कंडीशनिंग क्वेश्चंस एवरी ईयर. Specific humidity, this psychometry is basically important, and then rest all questions should be easy, to be frank. Okay, like the Rankine cycle or Barton cycles, these things are very easy. Focus majorly on air conditioning, and then the Rankine cycle questions. Okay, so this rest all auto cycle, diesel cycle, these things just the formula based questions and small theoretical points they come up, but it's okay. Okay, okay, fine. So this is the gamma function, so square root of pi. I'd like to give you one more value here. Gamma of 1 by 2 is equal to root pi, and gamma of minus half is equal to minus 2 root pi. You should take care of these two values. Okay, so square root of pi is the actual answer. So let's go to the next question then. Okay, it's fine. So let's solve this. The integral, very simple question. Do this question. The value, the integral minus 5 pi by 2 to 5 pi by 2 f of x dx, where f of x is this complete stuff. So clearly it's like integral minus a to a, since integral minus a to a f of x dx becomes 2 times integral 0 to a f of x dx if f of x is even function, which is f of minus x should be same as f of x, and 0 if f of minus x is equal to minus f of x. Okay, so this is what you have. So clearly in this integration, this first part is of this kind. Okay, so that integration would go to 0. Minus 5 pi by 2 to 5 pi by 2 f of x, which is this e power pi x square sin cube x plus 4 cos x dx. So this can be written as like integral minus 5 pi by 2 to 5 pi by 2 e power pi x square sin cube x dx plus 4 can be taken out of the integral, and this is an even function, so 2 4s are 8. That's all. Okay, and clearly this integration will give you 0 if you solve this. Okay, because it's an odd function. Laplace transforms are there in XC, generally no. Okay, but questions involving Laplace transforms, like which can be solved like this integral 0 to infinity integral, because you see this is like a transform. Okay, e power integral 0 to infinity e power minus 1 into x. So questions of this kind which can be solved using gamma functions and beta functions can come up. Okay, clear? Prashant, they won't ask you the question directly from the Laplace transform, but they can give you based on the kernel, like the basic Laplace transform definitions. Okay, yeah. So this is 0, so 8 into integration of cos sine 0 to 5 pi by 2, so 8 into sine 5 pi by 2, pi plus, what is pi by 5 pi by 2? 2 pi plus pi by 2, correct? So which is 1. So 8 should be the answer. Yeah, 8 is the correct answer. B, option B, 8 is the correct answer. Okay, yeah, of course. So solve this question. It's a good question actually. MCQ 2014, couple of marks. The exact solution of the integral 0 to 4 x square minus 4 dx is denoted by IE. The same integral is evaluated numerically by the trapezoidal rule and the Simpson's 1/3 rule, and are denoted by 1 by t and 1 by s respectively. The subinterval used in the numerical methods is h is equal to 2. Then what would be the case? Anyway, today is the last class, so just continue. Okay, Pratik. So, but at this point of time, see, first whatever the topics you have, make sure you work 100% on them. Okay, then try to go for the extra topics. And I'll tell you, many times students face this issue. They take maths very lightly. Okay, very light. I take a maths se kya hota? Kuch nahi. But maths does majority of the things. Okay, when you're solving technical stuff. Okay, let's say for example, if I'm solving heat conduction equation, for example, okay, where there is some internal heat generation, then I'll get some equation like this, at least in the 1D steady state. Okay, then definitely it's a auxiliary equation. You'll solve these equations. Okay, this is nothing but a linear differential equation, high order, second order with homogeneous side. So definitely it's always important for you to study maths. Okay, like you take majority of the fundamental subjects, majority like mechanics, you should know, especially in the calculation of centroids and all, you should know multiple integrals. Okay, then you come to strength of materials, lot of differential equations right from the beginning. Okay, then machine design, again of course some empirical results, but theory of machines, again you will calculate maximum torque transmissions, all these things. The calculus part is very important. Okay, so you come to thermodynamics. Up to first law it's happy storytelling kind, but once you come to entropy you have to do a lot of integrations. Then thermodynamic relations, the perfect maths. Okay, then properties of pure substances, again you need integrations for Clausius-Clapeyron equations and all. So again in ATD you look at the concept of mean temperature of heat addition in Rankine cycles, in any power cycle, of course. So these all things are very important. Okay, in fluid mechanics I need not tell you, people who studied fluid from me, these guys know what is the level of extent of maths that you need to solve to understand the fluid mechanics perfectly. Okay, many times people mock me in, see our fans are there, Hindu, Mahavir, these guys. When I teach fluid mechanics, they just say you're teaching just maths class, it should be renamed as applied maths, applied fluid mechanics. These guys used to mock me in the chat box, I still remember. Okay, but I'll tell you, if you go for any interview, you will be like tested very intensely, especially like BRC or ISRO, these things. Okay, BRC is like the fantastic interview, the best I have attended in my life. So you should know what happens when. Okay. In fluid mechanics, when you are talking about Reynolds transport theorem, you need limits, you need multiple integrals like the double integration. Okay, you need the table integration, volume integral. You have a lot of things to do. Chalo. So please don't leave maths. I have seen, even I'm sad to see that even very big faculties which are established, they are also saying that maths is not needed and all. But in reality, maths is big faculties is not in the GATE and all, but in general, everywhere in engineering colleges and all. So they don't treat maths as a very important tool. Maths is a very, very important tool actually, okay, to solve your physical problems. Okay. So what is this story then? So let's see. Exact solution of the integral 0 to 4 x square minus 4 dx is calculated. So firstly, let us try to plot this curve. Solution given function is x square minus 4 actually. Okay, let us plot this function. You're taking two subintervals. Okay, step size is 2, so you're integrating up to 4. Good. This is x is equal to 2, for example. To make you understand, I am putting things a bit broad. Okay. X, y, which is f of x. Okay. Now, if you plot the function x square is equal to 4, for example. Okay. So how do you get this? Okay, so if you plot this function, like if you put x is equal to 2 or x equal to minus 2, the answer is 0, of course. Okay, and then after the value keeps increasing, and at x equal to 0 it is minus 4. So let me do this 0, and at x equal to 0 this is minus 4, and it's an even function. If you replace x with x minus x, the function remains same, so it should be symmetric about y-axis. So if you see, if you plot this, so some function like this, okay, it's a parabola. At x equal to 2 it is 0. Maybe I'll bring this little forward. Okay, so x is equal to 4. This is not up to the scale, but yeah. So now let's see the actual integration. If you calculate, I is equal to integral 0 to 4 x square minus 4 dx. Let's see. Okay, correct now? 64 by 3 minus 16. Yeah. So then if you simplify, 64 by 3 is like 21.33 minus 16, so 5.33. That's the exact value. Then coming to the trapezoidal rule. So at this point, this value is minus 4. This is 0. And at x is equal to 4, this is 12, because 16 minus 4 is 12, and you have two subintervals. So trapezoidal rule gives you h by 2. So h is 2, so 2 by 2 times of y0 plus y1. Here it is y1, and here it is y2. So y0 plus y2, so minus 4 plus 12 plus 2 times of this value, which is 0. So 8. This is 1, so 12 minus 4, it is 8. So trapezoidal rule in fact over predicts this value. Obvious, because if you connect it using straight lines, this curve lies below. Okay, so this predicts more than this. So IE should be definitely less than IT wherever it is. Okay, so let's see, IE is less than IT. So IE should be less than IT, which is not in this case. IT should be larger than IE, and IT is large in this case. Okay, so similarly if you calculate Simpson's one third rule, so Simpson's one third rule, if you calculate, IS is equal to 2/3 into y0 plus yn, so minus 4 plus 12 plus 4 times of 0, that's all. So 16/3, 5.6, no, 5.33. Okay, so this is what you should get, 5.33. So IE should be same as IS. Yeah, I am an idiot. Obviously no, it's a quadratic function, so Simpson and exact value should be same. Correct now? You remember in the last class I have told you the order of fitting polynomial for trapezoidal rule is 1 and the order of fitting polynomial for Simpson's one third rule is 2. So if order of fitting polynomial is 2, then if you are evaluating a quadratic function, IE exact value and I to the Simpson's one third should be the same. Perfect. Correct? So that's IE should be equal to IS. Got it? Maybe you can say it, since f of x is second degree function, Simpson's integral a to b f of x dx, Simpson's one third is perfectly same as exact value. That is IE is equal to IS. Okay, it should be same. Obviously, if you know this point, then no need to even do this calculations. Directly, you can understand that this IE and IS are equal, and since in trapezoidal you connect it by a straight lines, the trapezoidal area would be more. So IT should be large. So you'll first eliminate these two. IE and IS should be same. Then out of these two, you figure out IT is large. Okay, that can solve the problem for you. Okay, yeah. Then let's go to the next question. This is a good question. Okay, like I told that you'll explain sequences and series. I have given the D'Alembert's ratio test, but the linear equation trapezoidal give exact. Yeah, it gives. So in sequence and series, basically in the last 5-6 years, whatever the questions, not 5-6, almost like 7-8 years, whatever the questions has come up, those are only based on the D'Alembert's ratio test, which we have done. Okay, but it's okay. I'll give you some insights of Ch and integral test maybe in the Abhyas session time. Okay, just make me mind then, because today I think I have to go to many other questions. So, but those are like the very least probable topics, like the integral test and the Cauchy's test. But like in the last 7-8 years, you can see the syllabus, what are after the modifications even, you have the questions only from the D'Alembert's ratio, sequence and series. And in fact, last 2 years, there is no question from sequence and series. So make sure you go and you study and go for the exam today. Exam with this sequence and series. Okay, you study sequence and series. So some story is given about Euler's method, which is in syllabus. Using Euler's method to solve dy by dx is equal to some function y of 0 is equal to 1 with step size of h is equal to 0.25, the value of y of 0.5. 2013, couple of marks again, 2 marks. Okay, so let's solve this. Let's solve this. Given dy is what is the given dy? Some dy should be there, no? Yeah. So dy by dx is equal to 2 cos 4 pi x by 3 minus y, and this is your function f of x comma y. So what is the Euler scheme actually? Should we give GBG now? XE better? Yeah, let's solve this question. So this is the DE. So what is the Euler scheme basically? So Euler's, since nothing is mentioned, you can go with forward Euler. So yn plus 1 is equal to yn plus h into this function of xn yn. Correct? This is the iteration scheme in the forward Euler, right? Because if you look at forward Euler, if you have the slope, then you take 2 points xn, xn plus 1, yn and yn plus 1. So then definitely dy by dx is yn plus 1 minus yn by xn plus 1 minus xn is equal to y dash, which is this function. So this is the manipulation. So therefore y of 0.25, you are matching with step size of 0.25. So y of 0 plus 0.25 into this function of, you are starting from 0 and at x is equal to 0, y is equal to 1. That's what this condition tells you. Okay, at x equal to 0, y is equal to 1. So then let's see, y of 0 is 1. So 1 plus 0.25 into f of 0 comma 1. So if you put 0, cos 0 is 1. So 2 minus 1, that's all. So which is 1.25. Similarly, y of 0.5 is equal to, now since you are moving with step size of 0.25 plus 0.25 into f of 0.25 comma 1.25. That's all. So this gives you some value. Let's see what is that value. Y of 0.25 is 1.25, and this function here is, if you put x is equal to 1 by 4, then this is cos pi by 3. So cos 60 is 1 by 2, 2 gets cancelled, 1 minus of 1.25, so minus 0.25. So if you simplify this, 1.25 minus 0.25 square minus 0.25 square, so 1.1875. You should be very careful when you are putting the numbers. Okay, so that numbers, especially in this numerical methods, numbers are important. Okay, decimals. So 1.1875, it's in option B. Fine. Ashutosh, yeah, if you have doubt, please ask me. Ashutosh Sahu. It's a simple Euler method. Okay, since nothing is mentioned, you can move for forward Eulers. So in question 1, my coefficient is 0 because it's an identity. Okay, so आपने forward Euler method लगाया, yeah, it's a forward Euler method, right? It's forward Euler. If it's backward, then yi, it should be like y xn yn and yn minus 1 and xn. Okay, so yn minus 1 is equal to xn minus is equal to h into that function. So sometimes it ends up non-linear, then you will solve using Newton-Raphson technique. Okay, in question 1, basically here some of a friend has a doubt. Let's go a bit to make him understand stuff. So here, irrespective of any value of x, this is always 0. Okay, so then we should get this. How you solve numerical without calculator in HPCL? In HPCL, first of all, that kind of questions they come is not very complicated, to be frank. जब मैंने एग्जाम दिया था 2022 में, no sorry 21, okay, so 2021, 4 years now already. So it was like 170 questions and 150 minutes, I think. Okay, and the cutoff was like 152 or something for general, 153. Okay, and I was good enough to get some 154, 155 marks luckily, and then in interview I did the game very well. But because if you see in HPCL, the questions are very like the kind of questions they ask do not involve much calculations. Okay, in question if they don't mention, you can go with forward Euler because that's easy. Okay, because backward Euler can sometimes end up with nonlinear equations. Okay, that's the reason. So better to go with forward Euler if nothing is mentioned. Similarly, in Simpson's rule, if nothing is mentioned, go for 1/3. Okay, don't go for 3/8 unless they mention it. Okay. Thanks, Ashutosh. Sorry if I pronounce it wrong. Ashutosh Sahu. Thanks. But anyway, this question I hope you understood because it's an identity. So definitely, irrespective of the value of x, this equation should get satisfied. So ultimately, the coefficients has to be zeros. Okay. Fourier says 2013, 1 mark question. So let's see the Fourier series for the periodic function f of x is equal to mod x within the limits -1 to 1, and after it's a period of 2, f of x plus 2 is equal to f of x is given by this series. So the Fourier series expansion given f of x which is equal to mod x is equal to half minus summation n equal to 1 to infinity 4 times cos 2n minus 1 pi x by 2n minus 1 whole square into pi square. Okay, I have seen some legends cancelling this pi and pi. Please don't do that. Okay, that's the difference. Now what do you want actually? We want the series such that you have the summation of 1 plus 1 by 3 square plus 1 by 5 square and so on. Okay, so let's see at x is equal to 0, this gives you 0 is equal to half minus 4, you can take out, it's constant, pi square also you can take out, it's a constant, summation n equal to 1 to infinity. If you put x equal to 0, cos some term into 0, so cos 0 is 1 by 2n minus 1 whole square. This is what you would get, correct? And if you expand this, this is exactly this. Okay, so you can see pi square by 8. That's all. And if you expand this, this sequence will turn up. Okay, like for n is equal to 1, 1 by 1 square plus when n equal to 1 by 3 square and all. So pi square by 8 should be the answer ideally. Okay, here they have given you the Fourier series, very straightforward, so nothing to do. You should think what value of x you should replace so that you would generate this expression. That's the basic idea. So let's solve here. Okay, this is not in the syllabus anymore. Fine. This question we have solved, no? The heat equation question, yeah. Okay, so fine. So these are the questions that we thought of. Anyway, it's almost 3 hours, so 10 minutes less. This 10-15 minutes come because of the difference in the doubts. If more doubts keep coming up, then for every question, let's say on an average, if 30 seconds gets delayed, then for this complete loop of 20 questions, you'll lose some 10 minutes. Okay, that's how it gets balanced. Chalo, so basically I have solved all the PYQs which keep very repetitive in nature, like they come many times, so that whoever has attended these 3 sessions, definitely they'll get enough idea on solving questions that day. Okay, which you can sense even after while we are doing the paper solving after the exam. Okay. Yeah, so then we'll finish it off today. So basically we have finished till this point. So tomorrow Shivam sir will start thermodynamics at 2 PM, PYQs again, XE PYQs, and Apurv sir will start the solid mechanics at the evening slot. Okay, 7 to 10 PM slot. So be attentive for the next 3 days as well for the PYQ sessions. Then we'll start the Abhyas in the upcoming week. Okay, I think 9th is Saturday. No, 9th is Sunday. So till Sunday you have the PYQ sessions, and then 10th is Monday. So from then on 10th we have again I'll do XE new questions, especially from the potential flows and also transport theorem, then boundary layer separations, these things which are very exclusive topics for XE. And then Sandeep sir will take majority of the rest of the parts. Then again solid mechanics by Apurv sir and Bansal sir, and thermodynamics by Shivam sir and Vinod sir, and I'll take the maths Mahayujans, not Mahayujans, sorry, Abhyas. Okay, so Abhyas sessions. Okay, and this is a Telegram channel, like if you just scan this, then it would go to the Telegram channel. Okay, so last year, although I have completed weightage of first, let's go in a line. You are idle, thank you. Weightage of numerical methods around 2 to 3 marks. Okay, not more than 3, generally 2, luckiest cases 3. Okay, last year although I have completed the written exam but unable to crack the interview. Which one? BRC. Let first gate gets completed. Okay, then definitely focus on the written test once again for BRC. Then I'll talk about you know, the way out, how to attend interviews, how to do and all. So first focus on the written test. Okay, go it in a stepwise way. It will be done. Is it okay to decide subjects there in the exam because I have covered the complete syllabus and every subject is good? Should I decide it? If you are confident enough, it's okay. Yeah. Any tips for interview to crack as that I've told you? Okay. So then, thank you all. We'll meet on Monday afternoon 2 p.m. again to discuss some good things of fluid mechanics. Okay. Yes, I hope these sessions helped you. I did not solve very basic questions. I have solved some good questions, is what I believe, at least to the maths I know. So these are not, many of these questions might not have, you know, been very easy for many of you. At least to some of you it would be definitely easy, but for majority of the crowd these questions are not a very straightforward questions, especially solving the heat equations, or in calculus you have seen a lot of twists in questions. Okay, so I think these questions will definitely help you out. In fact, I thought of putting more tough questions, but after seeing the first day response, I thought of, okay, let's not do very tough questions and let's maintain some things. Okay, even for the Abhyas, I'll plan the questions such that maybe 2-3 questions are more tough, but majority we have the same level of toughness. Okay, and for fluid mechanics also, I'll solve Abhyas questions in a lot of stuff. Yeah, almost all the syllabus, but I'll give majority of the focus on Reynolds transport theorem, especially to linear momentum and angular momentum questions, and then potential flows. Okay, yeah, fine. So thank you. Then we'll meet on Monday at 2 p.m. Yeah, okay. Meanwhile, from tomorrow, Shivam sir starts thermodynamics and Apup sir starts solid mechanics. So do attend without fail. Okay, thank you. Good night.